What's up guys, welcome back to the channel. Today we're taking a look at radiators, specifically those found on liquid-cooled AIOs for your CPU, and the best place to mount them in your case, whether that be at the top as an exhaust or at the front of your case as an intake. Those are the two main schools of thought, or the two main methods on where to put your radiator in the majority of modern-day mid-tower chassis. So there are pros and cons to both, and today we're actually going to test both options to see which one reigns supreme. Now, the great thing about having your radiator mounted at the top of your case as an exhaust is that you're exhausting all the hot air from within your case outside of it. So it's actually going to be good for the rest of your internal components because you're ejecting all that hot air far away from them. However, you're also taking all that hot air and you're permeating your fin stack in that radiator with it. So that could potentially be hazardous for your CPU temps. When you actually have things like your GPU generating lots of heat under load and that warm air gets circulated inside your case and then passed through that fin array, that could potentially lead to higher CPU temperatures. We're going to find out whether or not it makes a difference today. On the other side of the argument, if you have a front-mounted radiator set to intake, you're pulling a lot of cool, fresh air from your ambient surrounding environment, which is generally cooler than the warm air circulating inside of your case. So that's good for CPU temperatures. At the same time, once that cool, fresh air permeates the fin stack, it carries away all the heat that was absorbed in that array, and it basically ejects it inside of your case. So now you're getting potentially warmer components apart from your CPU, such as your graphics card, which in most mid-tower chassis these days is mounted right in front of where a front-mounted radiator would be. So is this going to pose a problem for your GPU temperatures? We're going to find all that out today. And as you can already probably tell, there's an additional layer of consideration here when it comes to your graphics card. Are we talking about an open air shroud or an enclosed blower style card? Because that could also play a difference or play a role on how your CPU temperatures are affected, whether it's the radiators mounted at the top or front of your case. So we're actually going to be analyzing 4 different scenarios today. Top mounted radiator with an open air shroud as well as a blower style card, and front-mounted radiator with both of those same 2 video card options. And the school of thought behind the video card being an open-air shroud is that it's going to be ejecting and circulating a lot of that hot air that's being dissipated from the GPU into your case. So if you were to have a top-mounted radiator and an open-air shroud, is that going to pose an issue for your CPU now? Because you're generating more heat inside of your chassis that's going to now be funneled through that radiator at the top of your case. Conversely, if you're dealing with a blower-style card, you don't have to worry so much about hot air being spewed out from your GPU into your case because all that hot air is being ejected out the back. That's just how blower-style cards are designed for the most part. At the same time, you generally get higher temperatures on your GPU with a design of that style because you don't have as many exit points for hot air to just be dissipated all around it. It's more considerate. It takes one for the team, so to speak, for your other internal components by harboring all of the hot air to itself and having a smaller exit window to eject it out of. So we're going to be taking a look at those 4 scenarios today to see which one is the most optimal, what you should be looking out for, if it really makes any difference at all, and at the end of the day, which solution works best for your needs. So I already have all the hardware set up here. I guess we'll just go over everything. So as far as the processor we're using, we've got the Core i7-7700K. So we are dealing with the Kaby Lake architecture, the latest 7th generation core processors from Intel. That will be overclocked quite heavily to 5 gigahertz. And I wanted to really dial in an aggressive overclock for this test because I feel like if we were to run everything at moderate to low speeds, we wouldn't see as much variable difference between our thermals from test to test. So to really get an idea of how things are being affected, I wanted to crank up the speeds quite a bit. So 5 gigahertz is where we're at. I believe at 1.4 something volts, don't quote me. It's a little bit over 1.4, but it is running stable. I've done stability tests and all that. So that's going to be cooled by the Corsair H100i GTX V2, which is a 240mm radiator attached to that unit. We're also going to be using the stock fans that came with that liquid-cooled AIO, which are 120mm fans, of course, plugged directly into the wires coming off of the water block. Those are 3-pin connectors. There's no fancy fan curve that we're setting up here. It's just going to be running at the default balanced RPM speeds that come right out of the box. Additionally, for our motherboard, we've got the MSI Z270 Gaming Pro Carbon, and that's going to be paired with 16 gigs of Corsair Vengeance LPX memory at 3000 megahertz. We've also got 2 GTX 1070s that will be tested separately, of course. The first of which is the Zotac Amp Edition, which is going to represent our open-air shroud, and then we've got the Founders Edition from NVIDIA representing our blower-style card. Both of these cards will be running with a 100 megahertz offset on the core clock, as well as a 350 megahertz offset on the memory clock, as well as power and temperature sliders maxed to 11 to take full advantage of GPU Boost 3.0. Something to bear in mind, however, is that the Zotac Amp Edition card does come factory overclocked, so it will be running slightly faster than the Founders Edition, but any kind of big thermal difference that we see between these two cards under load is most likely going to be due to the cooler design and radiator orientation as opposed to running at slightly different frequencies. So bear that in mind. Additionally, we've also got a power supply in here, Fractal Design Integra 650 watt unit, and a 240 gig SanDisk Ultra 2 SSD, which is gonna have our operating system Windows 10 64-bit and all of our applications loaded up on there. Last but not least, we've got our case that we're rocking. The case is very important here, and it's probably going to be one of the biggest differential factors. If you guys were to test this at home, you might get completely different results than I am today based on the hardware you're using, particularly your chassis and how good the airflow is within that. So we've got the Define S from Fractal Design, and we are using some aftermarket fans here, not the stock ones that came with the unit. So we've got a rear exhaust 140mm Fractal Design Venturi fan. That is the case fan, not the static pressure one. That's going to be, again, our rear exhaust. And then we've got two NZXT case fans that came off of the Manta, either the Manta or the S340. They might actually be the exact same model fans, but we've got two of those, which are going to, their positions are going to vary based on where the radiator is. So in our test where the radiator is at the top of the case, those two fans are going to be mounted at the front. Did I say they were 120s? They're 120mm fans, if I didn't mention that. So they're going to be mounted at the front of the case when the radiator's on top, and they're going to be mounted at the top of the case when the radiator's at the front. Hope that makes sense. And that's also going to play a huge role if you have 0 or 1 case fan in your setup and everything else is identical here, you might see drastically different results. So bear that in mind. This is a very specific use case scenario, but I did try my best to pick some components that reflect a modern day high-end mid-tower that is going to be primed for overclocking, which hopefully is somewhat representative of some of you out there. So I think on that note, ladies and gentlemen, we're ready to fire up some tests with Unigine Heaven 4.0 back here. We're going to be doing 30-minute runs. So all 4 of the scenarios that we're testing are going to get 30 minutes a piece under load in this particular application. We're going to go ahead and circle back with the results, and we're going to see once and for all how the temperatures both on our CPU and our GPU might be affected by radiator orientation, as well as the type of video card shroud that we'll be using in this chassis. Should be interesting. Don't go anywhere. We'll be right back. I'll be right back. I'm alone. I'm always alone. All right, y'all. So we have run the tests, and I have the results here, and very, very telling numbers, actually. You guys are going to find this very interesting. So we're going to start off with the top-mounted radiator tests first. So both of those with the blower-style fan and the open air shroud, and see how those compared. So with a top-mounted radiator set to exhaust, our blower-style card saw CPU temperatures all the way up to 77 degrees Celsius on the package, and our GPU got as hot as 83 degrees Celsius. Now, 83 degrees C on an overclocked Founders Edition GTX 1070 is perfectly normal, especially since we cranked the temperature slider all the way up with an MSI Afterburner. So that's not too big of a concern. 77 degrees Celsius on the package of our CPU is pretty warm. I mean, granted, we are overclocked pretty heavily to 5 gigahertz, but I wouldn't want to see any temperatures go beyond that. So let's see how we fared with an open air shroud with our Zotac card, also overclocked, with the same top-mounted radiator configuration. 86 degrees Celsius on our CPU. We went up, what is that, 9 degrees Celsius, just from going from a blower-style card to an open-air shroud. Our CPU rose 9 degrees Celsius just because we changed the type of video card shroud we were using with a top-mounted radiator in the mix. Our GPU, of course, with a Zotac aftermarket add-in-board partner cooler, is going to be a lot cooler than Founders Edition, which is expected, so we had 71 degrees Celsius on that, on the GPU, which is going to allow us to hit higher boost clock frequencies as well. So that's good. So great for our GPU, not so hot, or actually very hot in a bad way, for our CPU. Now things get really interesting when we switch to the front-mounted radiator. So with the blower-style card and a front radiator, we saw a CPU temperature of 76 degrees Celsius on the package and a GPU temp of 84 degrees C. Now that's not the interesting part, because that's pretty much exactly what we saw, almost identical to what we saw with a top-mounted radiator and that same blower card. So we went from 77 to 76 on the package, so we went down a degree for our CPU, which makes sense if we're going to be dealing with a front-mounted radiator this time, pulling fresh air again from the outside ambient environment, and then 1 degree higher on our GPU, which also makes sense, because now we've got slightly warmer warmer air coming in after it permeates that CPU radiator that's headed straight for our graphics card. So overall, there's a little bit of a change on both sides, but not huge. It's very marginal. It could be subject to margin of error as well, so nothing too big to fret on that end. However, this is where it gets crazy, is when we switch to an open air shroud on our video card, like the Zotac Amp Edition, and we have a front-mounted radiator again, 76 degrees Celsius on the CPU package. So remember, with an open air shroud, when it was a top-mounted radiator using the same video card, we were at 86 degrees C on the CPU package. So we just dropped 10 degrees on our overclocked 7700K by simply switching the radiator from top to front. That is huge. That is completely massive. That's the only thing that we changed. On the GPU front, we got 71 degrees Celsius, which is pretty much staying in tune and consistent with what the Zotac amp card has been delivering throughout today's testing. So that's nice to see. And you can see there that actually brings up another huge point. The graphics card is hardly affected. Actually, whether it's blower or open air, it's hardly affected. It does not care where the radiator is. It might go up a degree or down a degree, but for the most part, your CPU temperatures, your CPU is not going to be emitting nearly as much heat inside your case as the video card is if you're dealing with an open air shroud. That's why the CPU went up 10 degrees as soon as we had the top radiator ingesting all the hot air through its fin stack. So that's really interesting. If you guys are rocking a open air shroud on your video card, which these days most of us are, and you have a liquid-cooled AIO for your CPU inside of your case, if you have the option to mount it to the front, I would very much do so. And I'd be curious to hear what your guys' results are if you were to test it yourselves at home. Have your radiator mounted at the front, do a half hour of Unigine Heaven there, and then have it at the top and do another half hour, and just compare the CPU temperatures to see if you're getting consistent results with what I am, because that would be very, very, very enlightening and very insightful. Not enlightening, be insightful. I'm using the wrong words now. But at the end of the day, there you guys have it. I already sort of anticipated that the CPU temperatures would be higher with an open air shroud if we were to mount the radiator at the top of the case, but I did not foresee it being a 10-degree difference simply from moving the radiator from one position to another. So that's very interesting. I thought this was a fascinating test. Despite my hypothesis already being correct, it just kind of took it to the extreme and went a bit further than that, blew my expectations out of the water. But let me know what you guys think, which orientation you have your radiators mounted in your chassis, assuming you have liquid-cooled AIOs on those CPUs of yours, and if it seems to make much of a difference, whether it's mounted to the top or the front, or if you're going to be doing any further testing, feel free to also share your results in the comments so that we can all see it. But that's pretty much going to do it for this little test, guys. Let me know what you thought in the comments below. Feel free to like the video if you enjoyed this type of experimental content. And that is pretty much going to do it for now. Thank you all so much for watching. Subscribe to the channel as always if you don't want to miss any more tech stuff coming up in the future very soon. And until next time, I guess I'll see you guys in the next video. Have a good one, guys. Bye.